So welcome to my YouTube channel. Today we will start with another method to solve our differential equation. As we have already done our first method when your equation is not exact and your equation is of the form homogeneous, then how can you solve that type of equation when your equations are not exact? Now for going further, we will do with today second rule. This is the same that in a first case, if your equation is not exact, then what we will do? We will find integrating factor, then we will multiply that integrating factor with our equation, then we will find the solution of that equation. In a same series, we will see the rule number second. Suppose that our equation is like mdx plus ndy equals to 0. Suppose this equation is not exact. If this equation is not exact and your equation is homogeneous, then we will go with the rule 1. If your equation is not exact and your equation is of the form f1xy y dx plus f2xy x dy, then in this case we will find integrating factor, that is 1 by mx minus ny, where mx minus ny is not equal to 0. So if our equation is of the type this, then we are finding integrating factor by this method, and then we will solve the equation. So from this, firstly we will see one question based on this so that we will get a better knowledge. Suppose that our differential equation is like, it is x square y square plus xy plus 1 d y dx plus then x square y square minus xy plus 1 dy equals to 0. Now firstly, before going further to find integrating factor, let us check that whether this equation is exact or not. Because if our equation is not exact, only then we are finding integrating factor. Otherwise, there is no need to find integrating factor. So if I'm comparing this with mdx plus ndy equals to 0, where our m should be like y x square y square xy plus 1, and our n is x square y square minus xy plus 1. Sorry, in equation here is also x. So here is the x. So see, it would be x square y cube plus xy square plus y, and here should be a x cube y square x square y plus x. Now as we know that to find the equation is exact or not, what we will do? We'll find del m by del y and del n by del x. If these two values are same, it means that the equation is exact. If these two are not same, it means that equation is not exact differential equation. So let us check firstly del m by del y. As we know, if we are finding here partial derivative with respect to y, it means that we are taking our x as a constant. So it can be derived by parts. So it is x square y cube. It should be a xy square. It should be a y. So as we can see, its differentiability is 3y square x square. It should be a 2xy. It should be a 0. So it is 3y square x square then plus 2xy. So this is the value of our del m by del y. Similarly, we are finding for del n by del x. Let's have a look for del n by del x. that is del by del x. What is the value over here? X cube y square. That should be a x cube y square minus x square y. It's my mistake. It should be a x square y then it is a plus x. Again, if we are finding partial derivative with respect to x, it means y is treated here as a constant. So it should be a del by del x cube y square minus del by del x square y plus del by del x over x. It should be a 3x square y square. It is 2xy. Here would be a 1. Here is my mistake again. It should be a 1 because we are finding partial derivative with respect to 1. So you can see that these two values are not equal. Our del m by del y is not equal to del n by del x. It means that this is not exact differential equation. So if our differential equation is not exact, it means that what we are doing here, we will find integrating factor. Now as we've seen that this is not a homogeneous, so previous method should not be applicable over here because it's the power is here is power is a combined power 4, here is a 2, it is a constant. If we will multiply, again we are not getting a homogeneous equations. So it means that we will go with the next because this equation is of the type this. Then what is our integrating factor? It should be a 1 by mx minus ny. So as we know what is the value of our m, the value of m is here, that is a x square y cube xy square plus y. The value of n is over here x cube y square minus x square y plus x. So see, we will solve it. That is 1 over mx means x square y cube plus xy square plus y x minus, here would be a x cube y square minus x square y plus x multiply with a y. So here we will get here it is x cube y cube. It should be x square y square. It should be xy. Again it is x cube y cube negative negative positive x square y square positive and negative is negative xy. So if we will solve it, we will get here this should be cancelled out with this should be cancelled out with this, and we are left only with 1 by 2x square y square. So it should be our integrating factor. As we have done in our previous method, after finding integrating factor, what we will do? We will multiply this integrating factor with our equation. So see, that should be what is our equation? X square y square plus xy plus 1 y dx plus x square y square minus xy plus 1 x dy. So we will multiply this integrating factor with our equation. So if we are multiplying, it would be a 1 by 2x square y square. If we are multiplying again, it is 2x square y square. Now have a look. This can be cancelled out. So we can do one thing. X square y square divided by 2x square y. Further, this will be go xy over 2x square y 1 over 2x square y, that should be our dx, plus again x and x should be cancelled out. It should be a x square y square over 2xy square. It is xy 2xy square. It is 1 by 2xy squared dy should be equal to 0. Now if we further solve it, e should be cancelled out, d should be cancelled out. You will left only with y by 2 plus cancel out. This is cancel out. That is 1 by 2x then plus 1 by 2x square y dx. After that, this is cancel out. You will get here x by 2 minus, then here is 1 by 2y, then 1 by 2xy squared dy. So now this is our new equation in terms of mdx plus mdy. So from here, this is the value of our m.